Welcome everyone to Are Your Developers Super Secure Coders? My presentation today will be discussing Are your projects discussing secure coding throughout all phases of the software development lifecycle? And are your developers super secure? Do they have all the tools they need to be super? Topics discussed will be throughout, do your teams use secure coding guidelines, best practices, secure coding standards, and checklists? And do they use them throughout their agile team meetings? As well as we will be discussing secure coding training and certifications. My background is a secure cyber engineer at Raytheon in Indianapolis, and I've worked there for 30 years. I have a master's in cybersecurity and 2 certifications in secure coding, and I'm working on my third. I use secure coding frameworks and SCA tools and help teams to analyze issues. I also give training on the SCA tools and help programs with secure coding and help them to understand how to use those tools and how to use secure coding. Okay, let's get a little bit of a background. Everybody understands actually how to use secure coding and all of the terminology. You've heard these things, but actually, do you know how to use them or how to actually include them in all phases of your coding or secure coding projects? Let's start at the beginning. Design phase. Let's learn how to use a guideline. First of all, each project can actually create their own guideline. It depends on your type of organization. Each type of organization is different, so your guideline will be different too, depending on the type of software you develop and the type of languages you use. Your guideline will be different there too. You can give different generalizations depending on your coding style, and it will also help you with usability and readability. So your guidelines will help with each of those phases. If you need different languages, we all understand different languages can get very complex. So making them more usable and understandable and readable is for future people picking up your code. Trying to take code that someone who's now left the company and then trying to have a new user read it. If you have code that is too spaghetti code, no, somebody can't do that. But using a coding guideline that everyone writes code in the same way, that is why you need coding guidelines. Secure coding examples. Code should not be too difficult to understand. Again, that's why you need them. Code should be well documented. Why are you doing something in this manner? Length of functions. Don't make your function like 200 lines. Everything should be simplified. Make it as small as possible. Make it the simplest function that you can be. Don't have, like I said, 200 lines. Don't use go-to statements, because first of all, when you go to try to debug after it's broken, okay, try to debug something when you have go-to statements. That's so hard when you try to use a compiler with a go-to statement, and when you try to use a static code analysis tool on a go-to statement, it's going to fail. Your static code analysis your SCA tools are going to say, no, go-to statements are bad. So yeah, your coding guidelines are probably going to say, try not to use them unless absolutely necessary. Advantages of using coding guidelines. You're going to have more efficient code because everyone codes in the same manner. Your users are going to have better and more efficient code because you can have someone pick up the code and say, hey, I can actually fix this because I understand it. If you have everybody write code in a different manner, it's going to have a little bit harder for someone to pick up someone else's code. You have a peer review, it's going to be harder. It takes time to go back and do a peer review if everybody writes code in a different manner. So, it's kind of hard. It reduces development time again because everybody writes this code in the same manner. Development's going to be faster because you can fix things quicker. Everybody's looking at the same code, same manner. Your development time is going to be a lot faster because, hey, everything's easier to find, and you can detect errors quicker because more things are more organized if you're using a coding guideline. Okay, best practices. Best practices are used because it makes things more rule compliant. That's what a best practice is. There's also things in a best practice that use things more like many types and variations of standards and guidelines. So things that are best practices are for like rules and guidelines that are, no, I shouldn't say guidelines here, rules for coding standards. Let's go to that one. Commenting and documentation again fall in here, but it's consistent indentation, consistent naming schemes. So everyone might name the same way. If you have every variable of a certain type. I know this might go back to the way we used to do it when I first started coding. All numerics started with an N. I know that's way back there, but I know it made it a lot easier to know that it was a numeric. Okay. All integers started with an I. Things like that. Hey. Avoid deep nesting. Don't have if then else, if then else, if then else. Your your static code analysis tool is going to catch that, and it will actually say, hey, some of these ifs don't actually go anywhere. These are never going to get caught. Sometimes people put ifs in and they are never actually used. So make sure that you're actually using all of those if thens. So make sure your deep nesting is actually useful code. Limit line length. Make sure that when you have your code, don't have all of your code actually on one line. I know that some languages allow you to actually have your whole statement on one line, but then go and try to debug that when you have an error. Yeah, that's not pretty. So make it so that it's a little bit more usable. Another best practice, yes, capitalize SQL special words. Not everybody does that. It's just good practice, best practice. Other best practice, don't use magic numbers. Okay, come on. We all do it. I remember doing it in the old days. I had a program that said, no, do that. Put it at the top, assign it to a variable, make sure you comment, say this is why this number is here. And that way, if you come back later and you need to change it, you know why that variable, that magic number is in your code. Because if you just assign a number inside your code and somebody needs to change that variable for some reason, they don't know why that variable is there. It's just a magic number. Where'd that number? It got pulled out of a hat somewhere. Nobody knows where that number came from unless you put a comment in there saying, that's what this number means. Assign it to a variable. Put a comment. Say what this magic number means. But don't just put a variable or just don't put a magic number in your code. Validating your input. Oh my gosh, really? Always validate your input from external sources. That is like the best practice ever. Always validate. always, because you never know where that variable, that value is coming from. Always validate. And error handling and logging. Okay, we all should have error handling and logging, but do we? Your static code analysis tool is going to catch you on error handling. Logging, not so much, but error handling, it's going to catch you. And okay, using compilers, highest warning level. It's not going to, static code analysis tools most likely are not going to catch you on that one, but your security people might catch you on that one. And denying access by default, that one is also a security person's, they might catch you on that one too, but that's a best practice too. Don't allow access to functions or areas unless the software really needs it or a person needs it. Deny access by default. Just only things that need access to a certain area or a person. That's people, really. The software should only have access to an area if it needs it. Don't let your software have access to everything. Okay. Some of the best practices mentioned. You can always use a code formatter to go in and fix some of the formatting. Now, code formatters, beautifiers, these all can be used on your code. I don't recommend it for some programs that you just go in and just boldly go in and format your code. I work with code that's been around for 20 years. I would not do this on that. No way. Because yes, it would be nice to have nicely code and beautified code, formatted and beautified code, but I don't know what it would do to it. It truly, it might break it. I don't know. If you're starting out a new program and you want to use beautifiers or code formatters on those, that's great. It's wonderful. But on legacy code, I'm not too sure that it would be a great idea. But things like this, it's awesome if you could do something like this in the very beginning and start from scratch. Because doing a code formatter and doing a style checker on your code at the very beginning, or even in the middle, if you could, getting this as something that you could actually run in your code, this would be something to do in automatic. This is the way to go. So these are all code formatters. This is a list. I was actually given this list at another presentation when I kind of gave a shrunken version of this presentation. They gave me, they just started flying at me, all of these style checkers. So these are beautifiers, style checkers, formatters, all kinds of different ones. So all of these are beautifiers that can be done for different languages, different code languages. So these could all be done. But like I said, I do not recommend them on legacy. For instance, this is unformatted code, all shrunk up. Not pretty at all. It, just not pretty. If we make it more readable, that is better to read and understand and can follow. That is what we want to see and understand. So that's more what you would want to see in your code. Okay, now we get to standards. Standards, secure coding standards are used to prevent security vulnerabilities from getting into our code. Now, we all understand the term standards, and I'm sure we've seen them, but not everybody uses them or knows where they are. So I'm just going to we're going to follow um, the SCI secure coding standards. With it, we've got the C and C++ coding standards from the SCI certs. They both have downloadable books at the wiki SCI site. They also have the SCI secure coding standards for Android, Java, Perl, C, and C++ at that site. But this site actually has standards where you can actually go and you can actually look at the standards to understand and read what a standard is, how to look through the code and follow what a buffer overflow is, what to do in the case of SQL injection, or actually look at when you actually get into your code and say a static code analysis tool and you see errors that you don't understand, you can actually go to these standard sites, because the static code analysis tool will actually give you links to the standards if you've got the correct checkers, that you could actually go to these sites and it will actually help you to fix your problems. And it will actually help you to understand possibly how to fix your code to make it more secure. These are, like I said, that I just gave the basic here, but these downloadable books, they are thick. I've got them actually downloaded because I actually have the C and C++ secure coding certification for professionals certification. So I actually had to download those books because I had to keep referencing for my certification. But that's a good place to go to get those understanding. We also have the NVD, the National Vulnerability Database, and that actually is where you can get an understanding of CVEs, or the Common Vulnerability Database or Exposure Database. And it actually can get you links to other scoring systems, the CVSS, the CWEs, CPEs. Those are other vulnerabilities that allow us to, those vulnerabilities will show up in tools like Coverity and Fordify, and you can actually go to these sites as well, and it will actually help you to understand, okay, these vulnerabilities, okay, how do I fix these? Where do these vulnerabilities, exposures, how can they affect my system? And these will actually give you platform vulnerabilities as well linked to your software. How can it affect my platform? Then we have MITRE, the CVE sites. It gives you the common vulnerability and exposures. It gives you languages and vulnerabilities and how to fix them. The CVEs, again, will be linked in your static code analysis tools. And it actually can give language fixes and different fixes in different languages. So you can actually get an idea how to fix whole bunches of different ways. It's a very good tool. I mean, it's a lot of different exposures, different vulnerabilities, and it gets updated quite frequently. So there's a lot of new ones coming through all the time. But you can also create your own secure coding standard. I actually have a link at the back of the my presentation, where you can actually create your own project specific secure coding standard, where you actually say, we are going to follow this practice. We're going to use this coding standard. We're going to use a checklist. We're going to follow these specific top 25 OWASP. We're going to follow, we're going to do this. We're going to do certain things. We're going to have, links to this. It's really pretty good, outline where it's got everything laid out, and you can actually just plug and play everything that your project, depending on your specific needs, has. And if you want to include certain things, you can. If you don't, you just leave them off the list. But I thought it was really a good starting point for a project to include a secure coding standard that way. But I've got it, like I said, I've got it at the end of my presentation. Okay, and now if we get to secure code reviews, we're going to discuss things like, if you include secure code reviews, do you use sprint planning, and do you do manual code reviews? And I'll discuss what a manual code review means in this process, in this meeting. And do you use automated code reviews? And do you use a tracking tool like Azure in this case? For me, a manual code review means that you are actually only reviewing the code that changed since the last time that you actually did a review. I'm not talking about a secure code review in the case of reviewing the code for vulnerabilities and reviewing the whole code base. I'm talking about using a secure coding checklist. I'm talking about checking the code that has changed, and including people that are like your domain experts. You need to include junior code reviewers, and you need a security professional. You need someone that can look at the code that's changed and say, hey, you aren't actually following secure coding practices. You might need to do a little bit more along this pathway when you're not including error handling in this procedure, or where you really should because of this. You're not using print F or sprint F when you should be, things like that. And some programs are still in the dark ages, and if they're not using an automated code review tool, things like that might actually need to get caught. And so some things that need to get caught might need a security professional that understands some secure code practices need to be in these reviews. And so if you're just reviewing a certain part of the code, you might need somebody that understands secure coding practices. You're not going to, like I said, you're not reviewing the whole code review, whole package. You're just reviewing what was made a code review in that change. But if you're making a change to one piece and they're already changing that little piece of code, hey, why don't you add this little bit and this little bit here and make it a little bit more secure. In the case of pros and cons, manual code reviews do find logical errors and flaws that can be found in the design and architecture that an automated review can't find. And in the case of this, you also can add experienced eyes, like a person that some of my some of my projects, we've got people that have been working on some of these programs for over 20 years. So you can add experienced eyes to some of these manual code reviews. Plus, you can add secure coding and AppSec knowledge to some of these reviews and have people that do understand both coding and AppSec knowledge to these reviews if possible. So you can share that with your teams. The only problem is that for the cons is you do need some experience in both language and frameworks, and not everybody is familiar with all of the languages being used. In our case, we need people that might have to be familiar with going all the way back to Ada and things like that. But you do need an understanding of security. So we again need to make sure that some of our people do understand security. We are lucky that some of our people do. Some of our developers do understand security, so that is good. But there is also the problem that if you don't use a checklist, you might get different reports. If you aren't using the checklist, your manual reviews are going to have a different look. And so using a checklist is very good in that manner. You get a same look from your manual reviews. So a checklist, if you can get one, should be like language neutral, because I know some of my programs, we've got VB, we've got C, we've got C++, we've got C# in one program. So if they could be language neutral, their checklist could be used all across the board. Offer a plan of approach to review the code changes. Make sure that they know at the very beginning their approach. This is what we expect. This is what we're expecting out of the review. And we don't want anything else. This is what we expect out of this review. And just say, we expect it to take this long, and that's it. Kind of like a sprint planning review. We aren't going to take any longer than this. This is all we're going to take. Don't take any longer when you're doing your checklist. Only take this amount of time. And so include an amount of time on your checklist. So sections on a checklist can include things like exception handling. Do they have exception handling in the code that was changed? Do they include auditing? So does the error in the error handling, does the error fail securely? Does the auditing, do they have enough information to reconstruct? Do they have, if it's sensitive, don't log it. For general information, libraries are up to date. Design sensitive information is not identified. Cryptography, sensitive data has been secured. A lot of ours are now web-based, so we don't really have to worry about that. But store crypto keys securely. Input validation, that one's a big one for a lot of programs. Data is checked for special characters before passing to SQL. Yeah, that one should be a big one on your checklists. Input restricted to only known characters. Validate numerics. Authorizations. Deny access to pages and data by default. Session management. Things like that. So, those are kind of things that you could have on a checklist. I mean, most programs won't have a lot of those, but there'll be some that will have certain things. It'll depend on the type of program, again, that you have. Well, next we'll talk about automated code reviews. Okay, an automated code review will be things that will be run from tools like an SCA tool, things that will be run and can do like a Coverity, a Fordify can go and do like a nearly full code coverage. It can be run during an automated build, and these are the two that I'm mostly familiar with. I know there's a lot more out there, but these are the ones that I'm most familiar with. And then when is best time to do the automated secure code review? Do it during your build development, and probably nightly scans are the best time to do it, and only when new code is added to CM, because those are the best times to do it. At least that's when I've found to be the best time to do it, is either when new code is added or nightly scans. It depends on how much code is being added to your repositories. Because if you've got a program that adds a lot of code all the time, then do it nightly. But if you have a repo that is only adding code once a week, not even that consistently, then only do it when new code is added. So that can tell you, hey, just do it when new code is added. So for Coverity, it's basically it can be run early in the SDLC. It can be tracked across the application. It is compliant with security and coding standards. Both cyber and software work together to find and fix the issues, and then it supports 21 languages. You can't really see that screen, can you? But basically, the tool allows you to actually look at the code, find, and up here in the corner, if I could actually, nope, I can't even show you. But it allows, up here in the very right corner, it allows you to actually look at a CWE and go right to the actual CWE website, so you can actually pull the information for it. Fordify also allows you to find the root cause of security vulnerabilities, and you can actually sort by the severity, get guidance and how to fix them, and then cyber and software can work together to fix those issues. It can actually provide support for 26 languages, and then it's actually able to work with all these different, both third-party, binary, web, and mobile. But you can also use SCA tools on the desktop. We have Coverity working on desktop, and we have developers that can find and fix Coverity issues or security issues earlier in the SDLC and they can actually, if they find them earlier before they actually get put into the repo, they can actually stop them from actually getting into the pipeline, and that actually saves time and effort. So we're trying to actually stop new issues from being injected. So that's helping us slow down that process of getting new issues. Plus, that allows them to actually fix more issues. They actually fix issues, and then if they find more issues around the issue that they were already fixing, they can fix more issues at the same time. So automated code review pros, they can fix, or they can detect low-hanging fruit and lots of vulnerabilities all at the same time. They can run test quickly and lots of code. It's can be done in an agile and continuous integration. It can be scheduled and run on demand, and then tools can be customized, and it is compliant for the different standards. Cons, it does provide false positive and negatives, although truthfully, I haven't found a lot of false positives, at least not in the recent years. Early on when we first set it up, we did find some, but in the recent years, we haven't found as many. It is dependent on the breadth of the tool. So again, we're using Coverity a lot. Fordify, we haven't really set up for a lot of programs yet. At least I haven't had access to it. I haven't played with it much. Learning curve, for those not familiar with the SCA checkers, yeah, there is a learning curve for using the tools. Of course, I've been using it for 10 years. And it is not viable for everyone, but there is open source. So it is possible for those that want to use open source versions. Code quality. You can use code quality tools to find code quality issues within your compilers. And issues can be found and can make better quality code. Now, static code analysis tools do find code quality issues, but if you use a code quality tool early and fix the code quality issues first, your static code analysis tool, will find less quality issues. Hint, use the code quality tools at the same time with your static code analysis. You might fix the issues early with SonarCube and StyleCop, and you would have less static code analysis issues. Anyway, so if you use code quality tools, your results can also be used during the manual code review. So SonarCube is one of those code quality tools, and it can find issues, those quality issues, and it can be used on 25 different languages. But it breaks down those issues as bugs, errors that can break your code, vulnerabilities. It says it's open to attack, and code smells, and it says issues that makes your code confusing. So that sounds like it really is a quality. And it looks something like this. And it can be used for Java, C#, C, C++, COBOL even. Anybody go back to COBOL days? StyleCop can be set up to run, for example, during a Visual Studio build. And it's also code quality and can be run automatically through TFS or Jenkins. And I've actually got some programs that are doing this, and it can be run in desktop mode also through your Visual Studio. But like I said, it can actually be set up to run through either desktop or through the Visual Studio and automatically through Azure. But I've got a couple programs running it automatically now through Azure. But you get example, for example, C#, and you get something like this. File header missings, closing brackets. It depends on how you've got it set up. But for example, this one just had 12 warnings. And if you click on the one warning, you can actually get some additional information. And it'll tell you exactly the cause, the rule description. And for training, these are all different secure coding trainings that are available. You have the Certified Secure Software Lifecycle Professional, the CSSLP, which is the one training that I'm actually working on right now. The Secure Coding in Java Professional Cert from SEI, Secure Coding in Java, Defending Web App Security Essentials from SANS, Secure Coding in C and C++, and then the Secure Coding in C and C++ Professional Certificate, which is what I have. And then there's a game. Secure Code Warrior has a secure code training game, and you can actually go out and get a demo license of it, and it's actually a pretty awesome game. You basically are going, there's a whole lot of different languages that you go from one place to another and it's basically they tell you find the error or the bug in this piece of code, and you have to go from one piece of code, find the bug, to this piece of code, find the bug, find this bug, find this bug. And once you pass one level, you go to another level, you get points on the board, and you are trying to beat adversaries and so forth. It's kind of like a capture the flag, but something like kind of like that. But it's really cool. So it was kind of neat. I started playing it, but I was also trying to get ready for presentations, so I didn't get to play for very long before my demo went expired. So, but it's pretty awesome. So basically, calling all superheroes, wanting just make sure that everyone tries to make sure that all of their developers are super secure. I tried to make sure that I included everything I could to just make sure that everyone knew where all of the places in your development lifecycle you could include secure coding practices, where what phases everything could be secured, and add secure coding practices. So thank you very much. Thank you for attending my presentation. If there's any questions, I need to go to Discord for that. Trying to